Hi children, today let us discuss third chapter, that is understanding the quadrilaterals. Before going to understand the quadrilaterals, we need to understand or we need to know some important terms in this chapter. First, what is plane surface? We can give some examples for plane surface like a sheet of paper, surface of your writing pad, surface of a wall. Like that we can give some examples for that. In that plane surface, if you draw some curves, those are said to be plane curves. But what is meant by a plane curve? When you join a number of points without lifting a pencil from the paper, then you get a plane curve. Suppose if I draw like this, you see here, without lifting my pencil from the paper, I drew this. So these are the plane curves. You see, now if I draw like this, you see here, now if I draw like this, here also I am not lifting my pencil, but here in this part I drew this line segment 2 times. So that means first I draw like this, once again I draw on the same line segment, I draw like this. So here in the brackets you see, without retracing any portion of the drawing. So without retracing, that means without drawing on the same line, we need to draw the diagram. Then only it will be a plane curve. But other than single points. So a plane curve, how can you get a plane curve? When you join a number of points without lifting a pencil from the paper, and there is a condition, without retracing any portion of the drawing other than single points, then you will get a plane curve. After this we have simple curves. What is meant by a simple curve? While drawing a plane curve, if one line is not crossing the other line, then that is said to be simple curve. That means whenever you are drawing like this, one line should not cross the other. Here one line is crossing the other. Here one line is crossing the other line. It is not a simple curve. So simple curve means a plane curve in which one line is not crossing the other line. That is what we say simple curve. Whether it is made up of normal curves or line segments or combination of those two, that doesn't matter. One line should not cross the other. That is the condition. Now closed curve. As the name suggests, closed curve means a curve which is closed. So that means something like this, closed. So that means here, if you observe, we can't recognize what is the starting point or what is the ending point in this case. So that is what we say closed curve. Suppose if I draw like this. Now here, this looks like it is closed. But here we can say this one is the starting point, this one is ending point. This is starting, this is end. Or we can say this is starting point and this is ending point. It doesn't matter. We can recognize one as starting point and another one as one point as the starting point and another point as the ending point. So it is not a closed curve. Now the combination of these two, that means simple closed curve. So what is a simple closed curve? It is simple as well as closed. Simple means one line should not cross the other. That is simple. Closed means that must be closed. That means we can't recognize a starting point and ending point. Then it is said to be closed. So the combination of simple and closed, that is said to be simple closed curve. So let me take one example. Suppose if I take like this. This is simple as well as closed. So this is simple closed curve. If I take like this, this is simple but not closed. We can enter like this into this one. So this is not closed. Even though this is simple, this is not closed. Let me take one more example. If I take like this, it is closed actually. It is closed but not simple, you see. Here at this point one line is crossing the other line. It is closed. Even though it is closed, it is not simple. So this is not simple closed curve. This is also not simple closed curve. The first one is the only one which is simple closed curve. Now let us do one match the following question. You see here, match the following. Caution, a figure may match to more than one type. So you see, first you see right side, simple closed curve. Simple means one line should not cross the other. Closed, you know, that must be closed. So you see, if you take the first one, that is simple but opened. Second one, it is not simple. Why? Because it is one line is crossing the other. Third one, you see, it is simple as well as closed. So we can say here, third one. Next, B. A closed curve that is not simple. A closed curve. First of all, let us look at what are the closed. These two are the closed curves. That is not simple. You see clearly, circle is a simple one. Why? Because one line is not crossing the other. In the fourth one, one line is crossing the other. So it is not simple. Right? A closed curve that is not simple is option 4. Next, see. Simple curve that is not closed. Simple but not closed. Not closed means it is opened. So clearly that is the first option you see there. In the first option it is opened as well as simple. Now next, not a simple curve. That is not simple. That means one line is crossing the other. Here we have those type of diagrams. Second one and fourth one you see. In the second one line is crossing the other, so it is not simple. In the fourth one also, one line is crossing the other, so it is not simple. So for this one, 2 and 4 both are the answers. Now let us see polygons. What is a polygon? A simple closed curve made up of only line segments is called polygon. Only line segments should be used to draw the simple closed diagram. That is what we say polygon. Here in the first 3 examples, you see this one and this one and this one. These are simple as well as closed, and all these 3 are made up of line segments only, you can observe. But in the second set of these examples, here also all the 3 diagrams are made up of line segments. But if you take the first one, that is not simple. Why? Because it is one line is crossing the other. Second example, you see here also one line is crossing the other, so it is not simple. In the third one, it is simple but not closed. It is opened. You can see, you can enter like this into this area. So it is not closed. Even though these 3, the second set of examples, these 3 are made up of line segments, those are not simple closed curves. So those are not polygons. Only first 3 set of examples are. Now we can classify polygons according to number of sides or number of vertices. So if there are 3 sides or 3 vertices, then that is said to be triangle. We know that tri stands for 3. Similarly, quadra or quad, that is stands for 4. Penta stands for 5. Hexa stands for 6. Hepta 7. Octa 8. Nona 9. So like that, according to the number of sides, we can classify the quadrilaterals. 3 means triangle, 4 is quadrilateral, 5 sides means pentagon, 6 sides hexagon, 7 sides heptagon, 8 sides octagon, 9 sides nonagon, then we have 10 sides decagon, and like that. There are n sides means the polygon is said to be n-gon. Now you see diagonals. What are the diagonals in a polygon? A diagonal is a line segment connecting to non-consecutive vertices. Non-consecutive vertices. Consecutive means, what is meant by consecutive? Consecutive means side by side. So non-consecutive vertices means the vertices should not be side by side. Then the line segment joining those 2 non-consecutive vertices of the polygon, that is said to be diagonal. If I take one diagram like this, you see here. So suppose let us take A, B, C, D. For A, B is the consecutive vertex, and for A, D is also consecutive vertex. So non-consecutive vertex means for A it is C, for B it is D. So if you join these 2, this line segment is connecting non-consecutive vertices. So this is a diagonal. Similarly, if you join these 2, B and D are the non-consecutive vertices. So this is also a diagonal. Here you can see in the first diagram, these are the two diagonals. In the second case also, the dotted lines are the diagonals. In the third one also, you see L, M, these are the consecutive vertices. So L, M, N, if you take L, M, N, the line segment joining L and N, this is the diagonal. Similarly, KM is the diagonal. Now, interior and exterior part of a closed diagram. Suppose if I take a closed diagram like this, interior means inside part. That means this is the inside part, inside area of this diagram. This is said to be interior. Now, exterior means outside this diagram. This is what to say. This is what to say exterior. This is exterior. And this is interior. Inside part. Interior means inside. Exterior means outside. That's it. Now let us see convex and concave polygons. Convex polygon means in any polygon, if we draw diagonal, if all the diagonals are in the interior of that polygon, that is said to be convex polygon. Suppose if you take first set of the diagrams you see here, this is the diagonal, this is the diagonal, this is the diagonal, this is the diagonal, like this we can draw so many diagonals here. In this diagram, all the diagonals are in the interior of the polygon. So this is said to be convex polygon. This is what we say, convex polygon. Not only for this, if you join, you see here, if you draw the diagonals like this, these are in the interior of this polygon. So this is also said to be convex. So like that, all these are convex polygons. Whereas in the second set you see, if you join these two, you see here, if you join these two, this is a diagonal which is in the interior part. Let us draw one more diagonal. So if you draw like this, this is not in the inside. This is in the exterior of the polygon. So this is said, these type of polygons are said to be concave polygons. You see here, to remember easily, you see concave. That means there may be one cave-like thing is formed like this. So you see here, this is just like a cave. This is just like a cave. This is just like a cave. Okay. So these are said to be concave polygons. So if you draw a diagonal like this, this is in the exterior of the polygon. Here also you can see here and here also, these diagonals are in the exterior of the polygon. So these are said to be concave polygons. Moreover, one more thing I can say, if you look at the interior angles, in convex polygons, all the interior angles will be less than 180 degree. All the interior angles are less than 180 degree in convex polygon. In case of concave polygons, at least one of the interior angle is more than 180 degrees. That means here, if you take this angle, this interior angle, this is more than 180. This is greater than 180 degrees. Then it is said to be concave polygon. So in a polygon, if at least one of the interior angle is more than 180 degrees, then that is said to be concave polygon. Next, regular and irregular polygons. A regular polygon is both equiangular and equilateral. Equiangular means a polygon in which all the angles are same, all the interior angles are same. That is what we say equiangular. Equilateral means a polygon in which all the sides are equal. That means lengths of all the sides are equal. If both are happened, then that is said to be regular polygon. For example, if we take a square, suppose this is a square. In this one, all the angles are 90 degrees. All the angles are 90 degrees. So it is equiangular and all the sides are equal. If all the sides are equal, that is said to be equilateral. So here in this case, equiangular as well as equilateral. So it is a regular polygon. Now let us take one equilateral triangle. Equilateral triangle. So in this equilateral triangle, we know that all the angles are 60 degree, all the angles are 60 degree, and all the sides are also equal. This is equilateral triangle. This is equilateral triangle. So here all the angles are 60 degrees, so equiangular. All the sides are equal, so it is equilateral. So it is a regular polygon. So in a polygon, if all the sides are equal and all the angles are equal, then it is said to be a regular polygon. Now let us see angle sum property. We know that sum of interior angles of a triangle equal to, we know that this is equal to 180 degrees. Suppose if we take a quadrilateral, suppose let me draw a quadrilateral like this. What is the sum of angles in this one? To do this, we can break this into two triangles like this. Now, in each triangle here, sum is 180 degrees, sum of angles actually this angle plus this angle plus this angle. This is equal to 180 degrees. In the other triangle also, sum of these three angles is equal to 180 degree. If you take the total angles, so that will be 180 degree plus 180 degree, which is equal to 2 times 180 degree. Now, if you take a pentagon like this, let me take the pentagon. So like this pentagon which has 5 sides. We can break this into 3 triangles like this, you see. 3 triangles. The sum of interior angles will be equal to 180 plus 180 plus 180, which is equal to 3 times 180 degree. We can generalize the sum of interior angles of a polygon like this. You see here 2 times 180, we can write this one as 4 minus 2 times 180. What is this 4? This 4 is nothing but number of sides of that polygon. Here 3 times 180, we can write this one as this is equal to 5 minus 2 times 180. This 5 is nothing but number of sides of this pentagon. So in pentagon we have 5 sides. So that is why the sum of angles is 5 minus 2 times 180 degrees. In general, if there are n sides in a polygon, then we can say the sum of interior angles equal to n minus 2 times 180 degrees. This is the formula to find out the sum of interior angles in a n-sided polygon.